So it's your chemistry class and fourth lecture in all, and we are doing chapter number 2, right? And what are we going to do today? Again, very brief revision. We are doing a topic of behavior of liquids. Surface tension we did yesterday. Today we'll see what are its impacts, and we'll wind up this second part of chapter number 2, the liquids, after studying vapor pressure. Okay. So viscosity we did day before yesterday. Viscosity means the internal hindrance, the internal resistance that a liquid offer to flow. Like honey is more viscous, it has more viscosity because it has its molecule has a large excuse me attractive forces among them. So if the attractive forces among the molecules are greater, it means the viscosity is greater. Then we did this yesterday, that weight or downward pull, like the weight of this guy who is jumping. The weight of this guy can be balanced by stretching a surface, right? This is the main extract. The weight of the guy, the weight of the boy is balancing here by the stretchness of this surface, right? So same is true in the case of liquids. The liquid molecules are tensed. The liquid molecules experience unbalanced forces. They are being pulled inside, right? I told you that we can divide all the molecules into two categories: one at the surface of the liquid, the other one which are not at the surface but in the bulk, but in the middle part of the, or in the interior of the liquid. The molecules which are there in the interior of the liquid, they experience balance forces. So suppose this is one molecule, then if one molecule, then if a molecule is attracting from this side, then from another from this side. If one molecule from this side, from the other one, from someone, then there is another one. Means this molecule is experiencing balance forces, whereas the forces at the surface of the liquid, unbalanced forces they experience. For example, here we have a molecule which is attracting downward, but there is no molecule over here. So this molecule will face unbalanced experience force, unbalanced. So all the surface molecules, they feel downward pull, and to balance this downward pull, to counterpart this downward pull, the surface molecule stretch themselves. They develop a force. What they do, they join, they develop a force, right, one after the other. So the whole surface becomes a stretchy one. Okay, so this stretchiness is called surface tension. So what is the proper definition? How much force is being there at the surface of a liquid per unit length, or energy per unit area at the surface of a liquid, right? And surface tension depends on intermolecular forces. If the molecules of the surface have enough intermolecular attraction, then the surface tension would be greater. If it's not, then surface tension would be less. Now, new thing. This part that we are going to do just now is not the part of our syllabus in a way that is not there in the book. But when you go for the entry test, then these questions are the normal ones. That is why I'm telling you. Might be you can see in these this subtopic in the notes also, right? So there are two types of intermolecular forces. Intermolecular forces means the forces between molecules. The forces between molecules. There are two types of forces. See, if the molecules are different, then we call this force adhesive force. Like suppose we have water in the glass, then the molecules of water is one kind, and the molecules of the glass is another kind. So if the attraction between these two is this is called adhesive force, right? And if the force of attraction is among the same molecules, like water molecule and another water molecule, same water molecules or same molecules, then this is called cohesive forces. So what do you mean by adhesive force? Adhesive means the attractive forces between two different kind of atoms or molecules rather, right? Right, as you can see over here. And what do you mean by cohesive forces? The forces between the same kind of molecules. If the molecules of petrol are there, then what is the attraction between among them between them? That will be the cohesive force, right? This is one part. Now, in some cases, adhesive force is greater than cohesive force, and in the other case, cohesive force is greater than adhesive force, right? If adhesive force is greater, then we see a meniscus. Meniscus means the top layer of the liquid, the top layer of the liquid, right? So we see a concave, a concave meniscus, a concave layer like this. Why? Because here, the liquid molecules will try to attract glass molecules. That is why they climb up from the corners. I repeat, here the adhesive force between the glass and the water molecules is greater than the cohesive one. That is why the water molecules are trying to climb the glass. That is why we see a concave meniscus, right? And if cohesive forces are enough, then they don't like to climb to the glass, and we will have a different kind of meniscus. Okay. Water on plastic. Here, the cohesive force is enough. Water doesn't like plastic, so it will not spread on it too much. But water on a cotton piece of cloth, here the adhesive force is greater. It will be absorbed. Water would be absorbed very easily in that cotton piece, right? Similarly, you can see over here that adhesive force and cohesive force. Here, the cohesive force is greater, right? That is why the water molecules, the water droplets are not going to be absorbed here. And you can see a concave meniscus in the burette. All right. So repeating, two kinds of forces: adhesive forces and cohesive forces. Adhesive forces between different molecules, cohesive forces between same molecules. If the adhesive forces are enough, then we see a concave like this one. If the cohesive forces are enough, then we see a different kind of attraction. Okay. Now this is the direct question. What is the effect of surface area? The effect of surface area is that due to surface tension, the falling drop of a liquid is spherical in shape. So if you see a short question, why the falling drop of a liquid is spherical in shape, then what is the answer? It is spherical in shape due to surface tension. Why? Because due to surface tension, the area reduces. See, when the water molecule is there, uh, some water is falling down, then water is being attracted from all the sides. As you can see over here, let me show you. You can see over here, all of these surface molecules experience inward pull. That is why the falling drop of water will attain a spherical shape. Okay, all the surface molecules are being attracted inside. That is why a falling drop of a liquid is spherical in shape. Okay, you can see over here, a falling drop is spherical in shape due to surface tension from, why? Because in falling drop, the surface molecules from different sides, from all the sides, they are being attracted inside. They have inward pull. That is why it will attain a spherical shape like this. So this is one of the effect of surface tension. We are just following our book. Another effect of surface tension is capillary action. If you take a liquid, or just think that there is a regular size soft drink bottle, and in that bottle you have inserted a straw like this one. So might be you have observed that the level of the soft drink in the straw is always to a high value, as you can see over here. Here you can see the liquid in the glass has certain, let me show you here. This is the level. This is the level of the liquid in the container. There's a level of the liquid in the glass. But when you put some straw, it is automatically will go little bit higher without doing anything. You can do it by yourself today, right? This is called capillary action. Means the rise of a liquid, the rise of a liquid in a thin tube is called capillary action, right? And what kind of liquid is this? In which the adhesive forces are greater. That is why the liquid will climb up. I repeat, the liquid will climb up in this thin tube. Why? Because the adhesive forces are enough. And if the case is reversed, if the cohesive forces are greater, then instead of going up, the liquid will go down. That is okay. So in capillary action, you can observe in both the cases. If the adhesive forces are enough, the liquid will rise. If the cohesive forces are greater, the liquid will go down, as in case of mercury, as you will see. So what is the definition here? The rise or fall of a liquid in a capillary tube is called capillary action. So capillary action is due to surface tension. So how the water can be transported in trees from ground to the tall trees? There isn't any pumping motor there. Even then, the water is going there. Why? Because just because of capillary action. We have imaginary tube of cells, xylem, through which the water is transferring from ground to the upper part. Or a blotting paper, a tissue paper can absorb. Why? Because Here you can see the capillary tubes are there, the capillary action is there, the the capillary action is, you can see over here, the tubes, the imaginary tubes are there through which the liquids are traveling, right? So this is one of the factor that why, how can it be possible to take water from ground to the leaves in a very tall tree, just because of capillary action. Now capillary action depends on the diameter. If you have a broader tube, you then the capillary action would not be so visible. You can see on the extreme right side, it has the thinnest bore diameter. That is why the capillary action would be maximum in this one. So what is point to be noted here? The smaller the size, the smaller the diameter of the capillary tube, more would be the capillary action. Okay, so very short topic. You already know from your previous grade 6, 7, 8, 9, 10 knowledge, whatever we are going to do right now. Volatile liquids. What do you mean by volatile liquids? Are liquids which can evaporate very easily in an atmosphere. Like if you leave petrol in a container, then it will be evaporated very quickly. Or the nail polish remover, or the thinner which is used in polishing the furniture. All of these are the volatile liquids. Why? Because they can evaporate very quickly. Might be you have observed that you forgot to cap your nail polish remover bottle, and sooner or after it all gone into the air. Evaporation, yes, you know, conversion of a liquid into vapors without heating is called evaporation. The conversion of a liquid into its vapors is called evaporation. So in evaporation, what happens? Liquid absorbs heat. Liquid absorbs heat. So that some of the molecules have high energy and they leave the surface and they come out. Suppose you have some water in a glass, then the process of evaporation would be continued over there. Why? Because the molecules which are there in the glass, all the molecules do not have the same energy. Some molecules have very high energy, some molecules have very low energy. So the molecules which have high energy, they leave the surface, they come out. We call it evaporation. Okay. So it's an endothermic process, means it absorbs heat. Physical process means we can observe it. It's a cooling process, right? Like suppose someone participated in a race. So, so after racing, his or her body will sweat. What is happening there? High energy molecules is coming out of the surface of the skin. They are coming out. So when high energy molecules come out, the body would be cooled. The body will feel at low temperature. So we feel cooling effect. That is why we always feel good in summers under a tree, because the process of evaporation, the process of transpiration is going on there. So transpiration or evaporation is a cooling process. Evaporation is directly proportional to the temperature. Means you know that wet cloths can be evaporated very quickly in if the temperature is high. Liquid which have a strong force of attraction have slow rate of evaporation. Like honey have strong molecular forces, so it won't evaporate quickly. See any question if you have? Condensation, this you also know. There is water molecules all around us whenever there is a cold object. Like you took out, suppose, a bottle from the fridge, then you will see the condensation there. So what is condensation? Conversion of vapors back into liquid is called condensation. So the evaporation was endothermic process. This is an exothermic process. Kinetic molecular theory decreases. Gaseous molecules have high kinetic energy, have high uh, ability to move, whereas this one has less. Means if you decrease the kinetic energy of gaseous molecules of vapors, then they will condense into liquid form, and the distance between the molecules is decreased. All right. So last 2 minutes. Last 2 minutes. Suppose we have a volatile liquid, as you can see in this bottle. So molecules are escaping out. They are coming out. They are coming out. Suppose a petrol is there, or nail pollution remover is there, or ether is there, or thinner is there. So the molecules are coming out. The naughty molecules, the high energy molecules are coming out, right? Evaporation. You can see evaporation. If the same bottle is capped like this one, it is capped. Now it's not possible for the molecules to escape away. They will remain inside. Sooner or later, their pressure would be increased, and the reverse process of condensation would be started. So here, in this case, when the bottle is capped, both the processes would be observed: evaporation and condensation. Like you put a saucer on a hot cup of tea. So initially, only the vapors, water vapors would be there, but as the time passes a little bit, you will see they will condense there. So this is called evaporation and condensation. Both are occurring at the same time. When initially the evaporation is faster and the condensation is slower, but as the time passes, the rate of condensation and the rate of evaporation becomes same. If 100 molecules are converting from liquid to vapors, then 100 molecules are converting into from vapors to liquid. If 1000 molecules are going up, then 1000 molecules are coming down. If 1000 molecules are going up, then 1000 molecules are coming down. Rate of evaporation is equal to the rate of condensation. When the rate of condensation and the rate of evaporation becomes constant, then whatever be the pressure there of vapors will have some pressure. That would be called vapor pressure. So what is the definition of vapor pressure? When the rate of evaporation and the rate of condensation becomes equal, then the pressure of the vapor is called vapor pressure. All right. And how can you measure vapor pressure? By using manometer. These are small topics, little topics. Under the heading of vapor pressure, you should know what is evaporation. You should know what is condensation. You should know what is vapor pressure. What is evaporation? Conversion from liquid to vapors without heating. What is condensation? Conversion from vapors back to liquid is called condensation. And if both the processes occur at some closed container, then the point at which the two processes occur with the same speed, then at that point, whatever be the pressure of the vapors is, that would be called vapor pressure. Okay, that's all today. Thank you so much. Allah Hafiz.